In this lesson, we're looking at getting information about a function from a graph. This includes describing different sections of a function, like when it's increasing, decreasing, or even constant. So we start out with a few basic definitions. We have some intuitive ideas of when a function's increasing and decreasing. So we know that a function's increasing when it is going up. And we have a technical definition here. A function is increasing whenever f of x2 is greater than f of x1 as we move from left to right along the x-axis. So if we looked at this graph here and labeled x1 as x equals 2, and let's say x2 as x equals 4, the output for x2 would be positive 4, and the output for x1 would be positive 1. Since the output is greater for f of x2 than the output in f of x1, the function is increasing. So we would see a positive slope in this case. If we move left to right and f of x2 is less than f of x1, we see our function is decreasing, which would result in a negative slope. But we also have a third option of constant. So a function is constant when the outputs are equal because the function has stayed the same. This would be a slope of 0. We have a graph of a function here, and we want to describe when the function is increasing, decreasing, and constant. And so I'm going to start off by highlighting when the function is increasing. We can see that it's going up here in the beginning, and then it stops decreasing once it turns. It has another section of increase in the middle, but it stops again, and has actually a third section of increase. So all three of these increasing sections we would describe using interval notation. And we're describing the x values for which the function is increasing. And that would happen all the way here from negative infinity up until we reach x equals negative 5. So we describe that first section as negative infinity to negative 5 with a parenthesis. And let me note something about the parentheses here in a minute. But the second section starts here when x is negative 1, and it goes all the way to when x is 3. So we describe that second section as negative 1 to positive 3, both with parentheses. The third section starts when x is 5 all the way to when x is 6. So for all of the x's between 5 and 6, the function would be increasing. Now notice I did include parentheses and not brackets on those endpoints here. If we look at what's happening when x is negative 5, it doesn't increase anymore. It is changing from increase to decrease. So that would not be included in my section of increase. All right, for decreasing sections, we see it is going down in that section between negative 5 and negative 1. There's another decreasing section here at the end of the function. So we describe all of the decreasing sections. That would be from negative 5 to negative 1, both with parentheses. And then another one from when x is positive 6 to infinity. So parentheses 6 to infinity. There's a last section about when this is constant. So this function is constant here when the function is flat. It has a slope of 0, and that's between 3 and 5. There is some debate about whether we use union symbols or whether we use commas to separate the lists. This is kind of a difference of what textbook are you using, what resource are we using to describe what the definition of increase and decrease would mean. For us, we are going to use commas between the different sections. When we look at a graph and see the increasing and decreasing sections, we also are finding some maximums and minimums. We have a definition here that says a local maximum value of the function f of x occurs when the graph of f changes from increase to decrease. So we saw an increasing section change to a decreasing section, and we get a local maximum. That local max has a maximum value of positive 7. So we get a maximum value, whoops, let's put this down here, a local maximum of 7 when x was negative 5. So I skipped the minimum one just based off of what the definition was first. So the local maximum was when the graph changes from increase to decrease. We went from decrease to increase, so a change from decrease to increase would show a local minimum value. That minimum happens here in this valley, and that's happening when x is negative 1. But the actual minimum value the function reaches is negative 5. So the local minimum of negative 5 when x is negative 1. Then, so let's go ahead and write that on my graph, local min. Then we have another change from increase to decrease here, which creates another local maximum. That has a local maximum value of positive 4 when x is 6. So you can have more than one local max or local min. What that local part is saying is if I zoom in on a section of the graph, so say I zoomed in only on this section here, I can see it change from increase to decrease, and it is producing a maximum value. Same way with here, if I zoom in on the local min, in this localized area, that is the lowest point in that area. Another name for a local max or local min is also a relative max or min. And that would just mean relative to that location, that is the max or min. Now there is also some terminology about an absolute maximum or minimum value. An absolute maximum value of a function is the highest point it ever reaches over the entire domain of the function. In this graph, we do see an absolute maximum. So this is a local max and an absolute maximum. In that case, the highest the function ever reaches is positive 7. And that happens when x is negative 5. Now we are going to do some shortcuts a little bit in our course just to make this a little bit more accessible. And we will usually just write these as the coordinates of where this local maximum or minimum will take place. So that coordinate would be negative 5, positive 7. An absolute minimum value would be the lowest point over the entire domain, and that's the point where it reaches its smallest value. We do have a local minimum, but that's not the lowest the graph ever reaches. That graph goes down to negative infinity, so it's going to keep going down forever. So there is no absolute minimum. All right, so we have two more graphs here on the next page for you to practice with. We're going to do this one together, and then for number 2, you can try one on your own. The first part wants us to describe when the function's increasing and decreasing. We will always describe the increasing and decreasing sections in interval notation. So I look for our increasing section, and I see one positive uphill slope here between negative 6 and negative 2. we're looking at the x values. So one of the increasing sections, is from -6 to -2. But there is another. So the other section happens here on the end that is when x is 5 all the way to positive infinity. So I'm going to put comma and then parentheses 5 to infinity. When we look at decreasing sections, we're looking for our downhill slopes. We have a downhill slope here from negative infinity all the way to -6. And then there's another decreasing slope, and that's from +3 to +5. Now, I did not include this in the directions, but we can describe when the graph is constant. That's here in this middle section. So I'm going to add that to my notes. But we have the graph is constant between -2 and +3. These are the x values, -2, and x equals +3. It does say classify all of the extrema. So as I look at this, a change from decrease to increase would be a local minimum. In that first section, we do have a local min. But there is another change from decrease to increase that shows another local min. If you look across the entire graph, the absolutely lowest point that the graph ever reaches is at -6, and that both both of those local minimums are at -6. So we would classify these not only as local mins, but also as absolute minimums. If we look for a local maximum, that needs to be a change from increase to decrease. And across this graph, we do have an increase section that changes to a constant, but it doesn't change from increase to decrease. A maximum should have a mountain peak in the graph, and this one does not have any. So there are no local or absolute maximums. But there are some local mins and absolute mins. So if we described all the local minimums, in shorthand, I'm just going to abbreviate the coordinate. So this is an XY coordinate. All right, and that would be at -6, -6. And then there's another one at +5, -6. There's also an absolute minimum that is the same at -6, -6, and at 5, -6. Now, if you're asked to describe what is the absolute min, let me answer that question for you. That would be -6. That is the absolute lowest minimum value the function ever reaches. If we were asked, when does it reach this absolute min? I am abbreviating, for a moment. So when does the function reach the absolute minimum is when x is -6 and when x is 5. All right, so there's another graph here for you to try, and you want to describe the same things. When's this increasing and decreasing? And if you want, you can add when it's constant, and then classify all of your extrema. When you're ready, you can go ahead and play the video, and I'll go through the answers with you. All right, so if you've paused and you've checked your or you've done it on your own, and you're ready to check your answer, this would show an increase section that is from -8 to -6. So we have -8 to -6. And then another increase that is from 3 to infinity. Now, notice that I used a bracket here for this -8. That's because we don't have the graph going on further. We have a closed point here at -8. We can see that it starts to increase right at -8, all the way to up until -6. Now that -6 is where it changes from increase to decrease. So we have a decreasing section that goes from -6 to -2, and then another one at 1 to +3. The graph is constant there in the middle. So it's constant from -2 to +1. We have a local maximum that's happening at -6, +3. There's a local minimum that happens at 3, -9. But that is also an absolute minimum again at 3, -9. In our class, we are just focused on gathering this information from a graph. But as you get to higher level maths, if you enter calculus, you're looking at how a function changes, and you're not always given a graph. You may just have the function of this algebraically. So we can use that function to describe when it is rising or falling, when it's increasing and decreasing. We can also find absolute maximums and minimums, or local maximas and local minimums. And it helps us answer questions like, what's the highest temperature in a day? What's the minimum cost to produce something? Or even what's the maximum profit a business can earn? As we learn about this in calculus, you'll hear something about derivatives. So if you've ever heard that terminology, that's when we will describe the slope of the line, and we use that to find these extreme values. So that's something to look forward to if you're going on into calculus.